Okay, so yesterday we started today we started creating our TurboShop, right? And we faced some problem. So that problem was due to I didn't pull, and then I didn't add the shipping proxy. Okay, so what is K8 TurboShop MongoDB alias? I'm just creating alias. Today it's going to be a short class. Sorry for that. We will complete this TurboShop and then end the session. First, we need to create namespace kubectl apply 01 namespace we have. Once we create a namespace, applying the MongoDB and then catalog, and we have created user and we have created cart. Redis also, sorry. kubectl delete -f manifest. Actually, first all the databases should be exist for our app tier applications to run. So MongoDB is running, and then so let me create Redis and let me create MySQL. Okay, and user cart shipping and then web. Now kube-ns RoboShop namespace. RoboShop. kubectl get pods. Okay, we have all the pods running. kubectl get service. Yesterday problem was I didn't add shipping in the web reverse proxy. Okay. So here in the instances, we should allow security group. Go to any worker node. There will be a security group created. Remote access. Just add all TCP. So usually you will add only the node port you are opening. Balancer is still running. Let us see it is healthy or not. It's healthy. So now we got it. Adding to the cart. The cart. So now we are getting shipping. Okay. So now next thing is RabbitMQ. Just copying the code. RoboShop Docker. So we don't have RabbitMQ as a customized image. So now I'm going to create one RabbitMQ folder, and let me just copy this manifest and then change it here. RabbitMQ. What is the RabbitMQ port number? Can someone please send in the chat? This RabbitMQ port number. 1063, no, I think 5672. Yeah, 5672. Yep, push the changes. And pull the changes. Click pull RabbitMQ kubectl apply manifest kubectl get bots. RabbitMQ is running. Okay, so now once RabbitMQ is running, we will go for payment. So let us copy the code. Eight workshop payment. Let's see the Docker file. So it has AMQP user and AMQP password. And what are the other dependencies? Okay. Cart host, cart port, user host, user port, AMQP host, AMQP user, AMQP password. So I will remove all these things here. I will add them to the config map. So create manifest.yaml. I'm copying shipping manifest. Just replacing shipping with payment. So usually manifest files are almost same. You can just copy and edit it once you are confident, because every application is here going to use deployment and then service and config map maximum. So now cart host, that is cart cart host, and then cart port is 8080, and then user host, that is user, User port is 8080. AMQP host, that is RabbitMQ. And then AMQP user and AMQP password. Okay. Yeah, this is payment. Push. Full payment. Docker build -t join DevOps slash payment colon 1.0.0. Building. Docker push join DevOps slash payment 1.0.0. Now we can push the manifest. kubectl get pods. Payment is getting created. Is running. Now let us check. It is error placing order. Now let us check kubectl. Why is the error? We know that. Go to web and then add the config. Reverse proxy. Push. Full web Or it is running now. Let's check this. Not check out. Wait, confirm pay now. Again error. Let us check kubectl logs. This is the payment URL. Okay, I think we need to log in for this. Let me log in. Register. Add to cart. Checkout. Still error. Okay, so let us see the error. Here it is shipping related. Payment. Here is payment 500. So let us check the logs of payment. kubectl get bots. kubectl logs payment. So we received the payment information here. Access refused. Okay, so the access is refused by AMQP. You can see the broker login was refused using authentication mechanism plain. Okay. So inside payment, we added RoboShop and then RoboShop 1, 2, 3. Let us just check. It is guest. Okay, here we haven't created any user through the RabbitMQ. So in payment manifest, I'm just removing this. By default, that will be guest and guest. So generally in a VM process, we were creating one user. Here, if you see, we were creating one user, but here we haven't created. So by default, it will use guest and guest. So it is fine. Just pushing it and then pulling. Payment. Kubernetes apply. And then delete the payment pod. It should work. Okay. Okay, so this is how we create RoboShop project. And then so the next thing is storage. So till now, data, we don't care about the data much because we are storing the data inside the pods only. So which one is easy? Which one you prefer generally, storing the data in your laptop or storing the data in hard disk? Generally, which one you prefer if the data is very important? Can someone please send me in the chat? So if the data is crucial, you always prefer to store it in hard disk because your laptop may crash at any time. So similarly here in our servers are not permanent. Okay, anytime you can delete the worker node and you can add the worker nodes, and you can increase the worker nodes, you can reduce the worker nodes. So storing the data inside the EC2 instances is not at all safe. So that is why generally we have a storage service called EBS and EFS, Elastic Block Store and Elastic File System in AWS. That is just like our hard disk. So you will keep the data separate from the instance. So whenever you create the instance, you delete the instance, your data is always safe and you can mount it to the upcoming instances. Okay, so that is the importance of storage. So yeah, so our app here, it's completely ephemeral. Application is always ephemeral because it will be deleted and then created again, but data is always eternal. It is permanent. Okay, so data, we will keep it in EBS and EFS, but application is going to be in EC2 servers. Okay, it is not a problem even you delete the application and you create the application again and again. You delete the server, you create the server again, not a problem. Always your data is important. Just like you can change any number of laptops, but if you store the data, important data in your hard disk, it can change any number of laptops. The same concept here. You can change any number of EC2 instances. You can add, you can delete, but the data is already exist. So storage is very important part of Kubernetes. So from next class, we are reaching a crucial stage. We will discuss about storage and then the whole setup, we will do it. Like infrastructure, EKS cluster through infrastructure, and then CI/CD complete deployment from CI to the Kubernetes deployments. Everything we will take care. Okay, so that is the final flow. So once we discuss storage, we will reach that level. But then you'll become, you can say, proper DevOps engineer. Any questions? Yes, Santosh Avla.
Yeah, hi Shiva, good morning.
Hi, good morning.
Yeah, Shiva, what about NFS also you are considered to storage purpose, NFS?
EFS is nothing but NFS. Okay. EBS is like hard disk. Hard disk always, we will keep the hard disk just beside our laptop. But Google Drive is one of the example of NFS. Google Drive is somewhere else. So we will store the files from our laptop to Google Drive. So that is network file storage. So through the network, you are sending files from your laptop to somewhere in US. But hard disk, it is just like sitting next to your laptop. So that is like EBS. Elastic block storage is like hard disk. EFS is just like Google Drive. So we will see that both, and then we will understand how they work. We will use them into our Kubernetes, and then we will set up the complete flow.
Okay, thank you, Shiva.
Okay, so Naga Prasad.
We have two more sets we discussed, daemon set and stateful set. Is it cover here?
So you have seen already, I covered it.
Was it stateful set and
No, I covered it or not?
no, I think I didn't cover.
That is a part of storage.
Okay, fine. Thanks.
That's all. Have a nice day and see you in next session. Bye bye.